Today we're going to be looking at quadratic formula and using it to solve quadratic equations, but we're going to be adding complex solutions to our quadratic formula. So before, when we would have said that the quadratic had no real solutions, now we're going to actually find the not real or the complex solutions. So it's really important that when you're setting up to solve for the quadratic formula with your quadratic equations, that you're making sure that the equation is equal to 0. That just makes sure that you are finding the correct A, B, and C values to plug into the quadratic formula. Again, you want to make sure that you identify the following: that A is the coefficient of the x squared term, B is the coefficient of x, and C is the constant. You do want to make sure that you're not thinking just that it's going to be the first, the second, and the last term. Sometimes they could be mixed up and not in that standard form. So you always want to make sure that they belong to the correct variable when you're finding the coefficient. And then the next step is just to take and substitute those values into the formula. And again, I've told you we need to work on memorizing the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4ac, which is our discriminant, all divided by 2a. After you plug in, you want to simplify under the radical. Be really sure to watch your signs. That minus 4 can get us into a little bit of trouble if we don't pay attention to that when we're simplifying. And then we're going to reduce or simplify that if possible with our fractions. Remember that you can only reduce if all of the numbers outside of the radical can reduce. So the number that we're adding and subtracting, the number in front of the radical, and then also the denominator of the fraction. And when it's possible, we do want to simplify that answer and write it as two solutions. So we're just going to work through several different examples. So for example 1, x squared minus 5x minus 36 is equal to 0. So for this one, remember that if we don't have a written coefficient in front of the x squared, it's a 1. The b value is a negative 5. So a, b, and c is going to take the sign of that coefficient. And then the same thing with our constant, it's a negative 36. And then we start to plug this in. So we would say our b value is negative 5. So everywhere we have a negative 5, or excuse me, a b, we will plug in a negative 5. Every place we see an a, we're going to plug in a 1. And then every place c is a 36. And remember that these are all multiplications here. Also, if you're using a graphing calculator and you're going to square that negative, be careful and make sure you put it in parentheses. If you don't, your calculator is going to tell you that it's a negative 25 because it thinks you're asking for the opposite of 5 squared. And then again in the denominator, that's multiplications. This is just like kind of a template to help you remember to make sure to plug all of those things into the correct place. So then we just start to work through and think through order of operations. So negative 5, sorry, that would be a positive because it's the opposite of the negative. So that would be a positive 5 plus or minus square root negative 5 squared is 25 minus 4 times 1 times negative 36. And so this is where I said in the start of the video that we want to be careful because 4 times 1 times negative 36 is negative 144. Which means that we're going to subtract a negative, so that changes it to a plus. So some students prefer to, in their calculator, actually multiply negative 4 times 1 times negative 36 because the negative times the negative gives them the positive. So you can do that in whatever way makes sense to you. But just be really careful with your signs because that's where we can make a lot of mistakes. And then we just keep simplifying again. Following order of operations, we need to work under that radical first. So 144 plus 25 is 169. all divided by 2. So luckily for us, 169 is a perfect square. So 5 plus or minus 13, all divided by 2. So that plus or minus means that we're doing two different things. We actually have two different solutions that we're working with in quadratic formula. We would have 5 plus 13 divided by 2 and 5 minus 13 divided by 2. So 5 plus 13 is 18. Divide that by 2. So one of my solutions is 9. And then 5 minus 13 is negative 8. And negative 8 divided by 2 is negative 4. So we have two whole number rational solutions here. So we would say that for this one, x is equal to 9 and x is equal to negative 4 would be our two solutions for the quadratic formula. In example 2, 3x squared plus 2x is equal to 3. So the first thing that we should notice when we look at this is that our equation is not equal to 0. And if I'm going to use quadratic formula, I need to make sure that that's equal to 0. So I need to move the 3 to the other side. So I would do that by subtracting that from both sides. So 3x squared plus 2x minus 3 is equal to 0. So in this one, a is 3, b is 2, and c is negative 3. So the opposite of b is 2. So that would be negative 2. 3 times c is negative 3, and then 2 times 3. On the next one, I'm not going to use this template, but I'm going to use it one more time. So again, that's just plugging in a, b, and c. So negative 2 plus or minus the square root. 2 squared is 4. So on this one, I'm gonna take that negative. I'm gonna multiply negative 4 times 3, which is negative 12, and then negative 12 times negative 3, which is a positive 36. And then that's all divided by 2 times 3, which is 6. So we're gonna have a little bit of work here, because when we get to simplifying, we have 40 under the radical, and that's not a perfect square, so we're going to have to use our factor tree. So again, we're thinking about two numbers that would multiply into 40, so we would have 4 and 10. 4 is a perfect square, so that's 2 and 2, and 10 multiplies out to be 2 and 5. So I have a pair of 2's that get to leave and go outside, and then the 2 and the 5 are going to stay under the radical. And if you notice when I'm working that I'm taking and I'm working kind of like left to right and I'm using these equal signs, you're going to want to make sure that you organize your work here, and that we can follow the line and the thinking. If you kind of write your work and answer all over the paper, that makes it difficult for me to read it, but it also makes it difficult for you to kind of go back and look for mistakes. So try to work left to right or straight down the page, and then use those equal signs to help you keep that work lined up. So we're going to look here, and what we want to think about is our fractions. We actually have two fractions. So we have a fraction here that we have to think about, the negative 2 and the 6, and then this positive 2 and the 6. So something that goes into all three of those numbers would be 2. So we can simplify that fraction by dividing out the 2. So we would have a negative 1 plus or minus the square root of 10, all divided by 3. So all three of those things got divided by 2. Sometimes you will see, so if we kind of come over here, sometimes you'll see people, they'll take and actually break this apart into two fractions. So if that is something that visually just makes more sense to you, then please do that for sure. So they took it and broke it apart, and then you can just simplify those two fractions. So this would be negative 1/3 plus or minus the square root of 10 over 3. So those two things are actually the same, and that would be a negative because it was a negative 2/6. So those things are the same fraction, the same answer. We've just taken it and written it in two different ways. And typically we don't take and split these apart into two different numbers, but you may see that, written on some tests or on other examples that you watch if you try to find any other videos. So just know that these can be split apart and written that way, but most of the time you're going to see me stop here and just say that x is equal to those two things, because we know mathematically that they're asking us to do both the plus and the minus for that one. All right, let's look at example 3. And I told you on this one I'm actually not going to use the template. If you like the template and you would like a copy, please just message me or email me and I'll be more than happy to send it to you. But I just like to use it at first till we kind of get used to this. So in example 3, it's equal to 0, a is equal to 1, c is equal to negative 50. But if you notice, I don't have a middle term there. But we still have to say, when we're using quadratic formula, that b is equal to 0, because it will be 0x. And then we're going to plug into our formula. So the opposite of b, it doesn't matter because it's 0. So we would say x is equal to 0 plus or minus the square root of b squared, which is 0 minus 4 times 1 times negative 50. And then all of that is going to be divided by 2 times a. So lots of zeros here. So because it is a 0 out in the front, I'm going to go ahead and drop the 0 and just write plus or minus the square root. It's 0 minus 4 times 1 times a negative 50. So again, we have that negative times the negative, which is going to make that a positive. So that ends up being positive 200 over 2. So plus or minus the square root of 200 over 2. So now we've got to come over here and we're going to simplify. 200 would be 2 and 100, 2 and 50, 2 and 25, and 5 and 5. So I have a pair of 2's and a pair of 5's. They get to come to the outside. And we multiply those together. 2 times 5 is 10. And then we have a 2 that's still under the radical because it doesn't have any partner on the factor tree, divided by 2. And, I left off my plus or minus, so we still have the plus or minus. And then we just have to simplify this fraction. Remember, I can't divide the 2 under the radical with the 2 in the denominator because the 2 in the denominator is not under a radical. So I can only divide the 10 by 2, which would be 5. So my final answer is going to be that x is equal to plus or minus 5 radical 2. Now honestly, that one is going to be easier to do by solving algebraically, but you can use quadratic formula. Again, you just need to be very careful and make sure you use zeros. So anytime you don't have a b value or a c value, you can plug in 0. You're always going to have an x squared. If you don't have an x squared, you don't have a quadratic, and so we couldn't use quadratic formula. All right, example 4. 5x squared minus 2x minus 1. So a is equal to 5, b is equal to negative 2, c is equal to negative 1. That equation is equal to 0, so I don't have to change anything. So x is equal to the opposite of b. B is a negative 2, which means it's going to be a positive in the formula, plus or minus the square root of negative 2 squared minus 4 times 5 times negative 1, all divided by 2a, 2 times 5. So we simplify. 2 plus or minus negative 2 squared is 4. Again, we're going to have negative 4 times 5 is negative 20. Negative 20 times a negative 1 is a positive 20 divided by 10. So 2 plus or minus the square root of 24 over 10. So we've got to work with this 24. So 6 and 4, which would break down to be a 2 and a 3, a 2 and a 2. So I only have that one pair of 2's to come out in the front, and 2 times 3 is 6, that stays under the radical, and then a 10 in the denominator. So again, we have this fraction, 2 over 10, 2 over 10. So 2 will go into all of those numbers, so we can simplify that fraction. I don't have to write the 1 in front of the radical. It would just be understood there that that's a 1, and then 10 divided by 5, 10 divided by 2 is 5. And so those would be my final two answers, 1 plus square root of 6 divided by 5, and 1 minus the square root of 6 divided by 5. And then example 5. So again, A is equal to 1, B is equal to 3, C is equal to 3, and then we're going to plug into the formula. So the opposite of positive 3 is negative 3, plus or minus the square root, b squared minus 4ac all over 2a. And we're simplifying again, so negative 3 plus or minus square root of 9. 4 times 1 is 4, 4 times 3 is 12, so this would be 9 minus 12 over 2. So here we finally arrived at our promised complex solutions. So this one I don't have to factor. If it was another larger number that wasn't prime, you would have to do your factor tree. But remember that this is going to be the same as the square root of negative 1 times 3. The square root of negative 1 is our imaginary number. And so we bring that I and we write it right outside of the radical. So that's the square root of negative 1. So now I have just the positive 3 left under the radical. If we had simplified that, if it had been a bigger number, we would have also brought that to the outside of the radical. And then you simplify the fraction the same way. We would have to check and see if there's other numbers that can be simplified. But negative 3 and 2 is the most simplified answer. So those are the two solutions. If we took those and wrote those separately, we would have negative 3 plus I radical 3 over 2 and negative 3 minus I radical 3 over 2. So usually the fraction, or excuse me, the formula part, we're good. It's when we start to throw in some of the complex numbers and simplifying the fractions at the end, it can get us a little confused. But again, they're all things that you already learned. We're just kind of applying all of them together in one type of problem.